All right, welcome. Today, we're going to dig into a really interesting text that looks at one of humanity's oldest, well, companions, fire. But this isn't just going to be a science lesson. We're diving into how the laws of combustion might actually reveal something much deeper, maybe even a kind of intentional design. So let's get right into it.
So, the source material we're looking at kicks things off with this really powerful question. It's not just asking about the mechanics of, striking a match. It's asking us to truly see, to really understand the force we're unleashing. And it's a force that has, quite literally, shaped our entire world.
I mean, think about it. On one hand, fire is the bedrock of civilization. It's the light that literally pushed back the darkness, it's the heat that cooked our food and kept us warm, and it's the energy that has powered, well, everything. It's an incredible creative force.
But there is a flip side. With just the slightest change in conditions, that exact same creative force can become this agent of just unstoppable destruction. The source points to the Hindenburg disaster, a massive passenger airship that was just engulfed in flames in 34 seconds. A terrifying reminder of fire's awesome power.
And that gets us right into our first section. To really get a handle on fire, you have to understand this fundamental duality. How can one thing be both a comforting friend and a devastating foe? Well, the answer is actually found in its basic science.
At its very core, fire is just combustion. That's the scientific term. It's a chemical reaction where a substance hooks up with oxygen and, in the process, releases heat and light. This simple definition, it's the key to everything else we're about to explore, both how fire works and, just as importantly, how we can control it.
So, if fire is a chemical reaction, then what's the recipe? This next section breaks it right down for us. There are 3 essential ingredients that absolutely have to be there for any fire to exist. You can think of it as the fire triangle. And here they are. You need oxygen, you need a fuel to burn, and you need a high enough temperature to get the whole reaction started. That's called the ignition temperature. Now here's the magic part. If you remove just one of those 3 things, you can't have a fire. It's that simple. Let's take a look at each one.
First up, we've got oxygen. It's what scientists call the oxidizer. Without it, most things in our world simply can't burn. It's the invisible ingredient that literally feeds the flames.
And this is just a brilliant way to see it in action. It's a classic experiment that the source describes. You've got a candle burning brightly in the open air. But the moment you put a glass over it, the flame starts to flicker, and then it just dies. Why? Because it used up all the available oxygen trapped inside the glass. No oxygen, no fire. End of story.
Okay, next up in our recipe, fuel. This is the actual stuff that burns. The wood, the paper, the gasoline. It's any material that has chemical energy stored inside it, ready to be released as heat and light when it combusts.
Now here's where the source takes this really fascinating philosophical turn. It suggests that the fact that some things don't burn, like rocks or water, isn't just a random accident. It's presented as a blessing, a kind of deliberate design to prevent a single spark from setting the entire world on fire.
And finally, we have ignition temperature. This is so crucial. Think about it. A log in a room full of oxygen won't just spontaneously burst into flame. The fuel has to be heated up to a certain minimum temperature before it will actually catch fire. And once again, the source sees a deeper wisdom at play here. The fact that fuels need to be heated up to ignite is presented as a kind of built-in safety mechanism. The idea is that fire is concealed or hidden inside the fuel, so it's there when we need it, but it's safely locked away, protecting us from, well, everything being on fire all the time.
Okay, so if we understand the recipe for fire, that means we also know how to unmake it, right? This next section is all about how we can control what seems uncontrollable.
So here's the key takeaway. Every single method of firefighting is just an attempt to break that fire triangle. When you pour water on a fire, you're cooling the fuel below its ignition temperature. You're removing the heat. When you smother a fire with a blanket, you're cutting off its air supply, removing oxygen. And when you create a fire break in a forest, you're removing the fuel. It's always about taking away one of those 3 key ingredients.
Of course, not all fires are the same, because not all fuels are the same. This is why we have different classes of fire. Class A fires, that's your everyday stuff, like wood and paper, and water works great on those. But you would never want to use water on a Class B gasoline fire or a Class C electrical fire. Understanding the fuel is absolutely key to choosing the right way to control it.
The source brings in another really powerful metaphor here, connecting the physical act of putting out a fire with a spiritual one.
The idea is that just as water can quench physical flames, an act of charity can extinguish sin. It's a beautiful parallel.
So now that we've covered how a fire starts and stops, let's zoom in a little closer on the most obvious part of it, the flame itself. I mean, what is it exactly?
Okay, this is a fantastic distinction made in the text. A flame isn't just something burning, it's burning gas. For something to have a flame, like a candle, the solid wax has to melt and then turn into a vapor. It's the vapor that burns. Things like charcoal, which don't really vaporize, don't produce a flame, they just glow.
And if you look really closely at a simple candle flame, you'll see it actually has different zones. The innermost dark part, that's just wax vapor that hasn't started burning yet. It's actually the coolest part. The bright yellow middle part is where incomplete combustion is happening, and that's what creates the yellow light and the soot. And that faint, almost invisible outer layer, that's where you get complete combustion and, believe it or not, it's the hottest part of the entire flame.
And not all fuels pack the same punch, not by a long shot. This chart shows what's called the calorific value, which is basically just the energy you get per kilogram of fuel. And you can see the huge difference. Wood is down there at around 17,000 kilojoules per kilogram, LPG is way up at 50,000, and then you have hydrogen gas with this staggering value of 150,000. You can see why it's considered such a promising fuel for the future.
And this all brings us to our final section, where we circle right back to the central theme from our source material. This idea of finding a deeper meaning, a sense of wisdom hidden within the cold, hard facts of science.
Here, the text uses fire in its most potent metaphorical form. A spiritual leader, the imam, is compared to fire itself, embodying that same dual nature. For believers, he's a source of warmth and light, like a comforting heaven. But for enemies, he's a consuming, purifying force, like hellfire. It's a striking image that captures that same friend and foe duality we started with.
And so we'll end here. This explainer has shown us how the source views the science of fire, not as some random accident, but as a system of carefully balanced properties that make our existence possible. And it leaves us with a final thought to ponder. What other powerful forces in our world, things like water, or atomic energy, or even human knowledge itself, walk that same fine line between being a profound blessing and a terrifying curse?